Hi, very exciting. I just received this package today and I wanted to open it with you. This is from Amazon, and guess what? I got the Seeeduino board, which is based on the RB2040. Let's open it and see. I just ordered it a couple days ago and I got it like today is Monday and I ordered it on Saturday. Really good. I'm very excited about that. Let's see. So it came in this envelope here, and I got two things. That's it. There's nothing else in there. So I got the Arduino XIAO. So here is the expansion board for the Arduino XIAO. Very nice. I think that's a lot of effort to they designed this board to help development and everything and speed up. So let's open it and see. It's very tiny. I mean, let me tell you, the small board for the Arduino already small, but this one also very small. Let's see. So you can see here the two connectors here, this one and this one, to put the Seeeduino board, and I believe this is the power pogo pins. Very nice. And then there's IOs and stuff. So here is I2C, and there is a power switch, which is 3. No, it's 2 position. There is an LCD in here. I have to look more into it. There is ground 3.3. You have a reset. And then here is the battery socket and the SD card. Version 1.0, just for reference. Very nice. It's a good quality board. Good labeling. As you see, the I2C has the right labels right there, and the other IO, I think, did a good job. And I believe this is an input button, 01 or D1. Then this is where the boards came in. So this is taped here. Let me open it. So yes, this is, it has a tape right here. I had to untape it. And another one right here. And now I can open it. Wow, looks so nice. So it seems like it comes all 3 inside here with the connectors. This one Doesn't look like the other ones I saw on the internet. It doesn't have that label, printed label on the chip here and shield. So let's see, it's a USB-C, and let me see, it has a pin out here. Which is labeled. So I have 0, 1, 2, 3, 4, 5, 6, VCC, ground, 3.3 volt, and 10987. Nice. And there is a ground and VN over here. On the other side, it's not really a lot of components on this board. It's very tiny, and I believe under the shield it has everything inside there. Okay, so I just discovered also there is of course these two headers, but also there is a sticker. That's what I was looking for, and you can place, you have 4 options, and you can place one of these 4 stickers on top of the the shield. They all basically have the same information, except they're just different formats. So interesting. So one here, it says, no, they all have exactly the same information. So let's go and do some more work with them. Okay, that is the next step. So I soldered the headers. I soldered the 2 headers onto the board, as you see. My goal is to plug it into my expansion board, so I'm just using this to just place my board for now. I'm not gonna really press it in. So first thing, I found out that it has already built in firmware or program that runs once you plug it in. It's again USB-C, and once you plug it in, as you see, there is a flash in LED to tell you the yellow LED to tell you everything is running good, and the green, it seems like it's a power LED. Or my plan is to put this board mounted on the expansion board, and you know, make use of the simplicity of and the features on this board. It seems like you have a lot of good peripherals and devices here. So from documentation, the SWDIO and SW clock are exposed for future debugging and connecting it to Seeeduino G-Link. If we have that option later. Again, that makes it easier for debugging at some point. Good. So again, I'm gonna place the board on the expansion board and make sure that they line up with the 4 pogo pins on the bottom, so they have a good connection. And looks like they do. Now let's plug it in and see how it works. Hello, so let's take it to the next step. Now we have the board connected and soldered and connected to the expansion board. Let's create a new project. We are going to use Visual Studio Code because of many reasons. It supports Arduino platforms and it supports specifically this board. Also, it's very popular and has a lot of capabilities. So, first time user on Visual Studio Code, we will have to go home and watch that little small toolbar down here. And this is home. Great, so we're home. We're gonna go to boards, and in boards, let's type or search for Seeeduino XIAO, and from there you should see that one here. And if you click on the Atmel SAM, you should be able to install it. I already did. It's in my system, so I cannot really install it now. As you see, it's already installed. Good. Now we did the hard part. From here, let's go to projects and let's create a new project. I'm gonna call that Seeeduino test 1, and I'm gonna select the board to be the XIAO, and you will see right there the Seeeduino XIAO, and leave the Arduino as the framework for now. Now, in my case, I don't install it or don't create the project in the default location. And once you select the location you want, the new project will create a new project folder for it. So you don't need to create a subfolder for it. Click on done, and it's going to take a little bit if it's the first time. Notice here the first thing comes up is the platform IO.ini, and this should be fine. So I would add this line here for the monitor speed is 15200. Save it. And let's close these, we don't need them anymore. Now your source file with the main.cpp should be right there. Once you open it, you will find that it's already populated with the setup. I just would start information here for your name and information of what you're doing. Good. So what we can do as a very start project, we will do the following. Great. So let's add these two lines. One is basically to print a line to the serial port, which is by default it's configured by the system, and we're gonna, let's say hello. This time let's say welcome to my new XIAO board test 1, and we're gonna put a little delay and see how that works. Okay, again, what we're gonna use that menu or this toolbar down here. This one here, if you pause or hover your mouse on it, it says build. This one is upload, and this one clean, and terminal, the serial monitor. Good. So right now let's do a build, and when you click on build, you will see some compiling information on a special terminal. Once it's done, it will tell you success, and let's go to upload it. As you hear that sound, you know that the board is configured for bootloader and uploaded and everything good, success. And now you can click on the serial monitor. You should see, welcome to my new XIAO board test 1. So we're success, we got it working. This is basically what we have for the first run. I'm gonna add one more piece to it. So good. So as you see, what I did, I added some more code. I created 2 variables, one for button pin, which reflects the push button that we have on the expansion board, and it says D1 on it, and then a state for that input, and it's started with initiated to 0. Then in setup, I am initializing the LED pull-in built-in to output. When the LED built-in is, again, just like the serial port, it's built in predefined in the system or SDK. And so I configured the LED built-in to output, and I configured the button pin, which is number 1, to be input pull-up. So it has a pull-up already configured on it. On the loop, I am going to read that input from the button pin, and I store it into the button state, and then I'm testing the button state. If it's high, I will write to the LED high, and if it's low, I will basically turn off the LED. Let's run it again. I noticed, by the way, that sometimes this causes a problem, so I go here and close them. I'm gonna build it again. Looks good. Then I am going to upload it to the board. As you hear the sound, you know the board is switching to a bootloader, getting the file, the new pen file, uploaded to it, and now it's ready. So the terminal really is not going to show anything. As you see, I didn't put any messages, which I could really add something, but let me get the video on the. So let me show you here. The board is all done with the upload. It has the new software that we wrote together. Now this is the button on the board, and it is D1, and the LED here is actually is I believe D13, which is built in for later if you decide to write to it. The code, it will go through the testing and then reads the button pin and assign it to button state, and from there it will turn on the LED on or off, depends on if you press in the button. So let's do that. If you press, you see the light goes on, the LED yellow light goes on. You release the push button, it goes off. Basically it's working. So now we have access to serial port, how to write debug messages to the terminal, and now we connect it to input and output on the board, the expansion board. Great.